two-stroke diesel engine piping system. The objective of this video is to familiarize student the piping system for the marine two-stroke diesel engine. At the end of this task the student should be able to 1. Draw and label with standard technical symbols all the relevant systems of the two-stroke diesel engine. 2. Know the function of each component within the system. 3. Explain the functions of each system. The two-stroke diesel engine consists of systems which is 1. The jacket cooling water system. 2. The fuel injection valve cooling system. 3. Main lubricating oil system. 4. Piston cooling system. 5. Rocker arm lubricating oil system. 6. Liner lubricating oil system. 7. Turbocharger lubricating oil system. 8. The fuel oil system. 9. Scavenge air system. 10. The starting air system. 11. Exhaust system. The jacket cooling water system. Fresh water is been pumped from water reservoir to the cooling tower by the centrifugal pump. In the cooling tower the water is been cooled by the contraflow manner that cools the water droplet for the purpose of cooling the system. The water will flow to a main piping system where it's distributed to a jacket cooling system, a hydrometer system. The jacket cooling pump of a centrifugal type pump the jacket cooling water to the L.O cooler where it cools down the lubricating oil of the main engine. The freshwater system also plays an important part of cooling the main engine jacket cooling system where it will flow through piping system through a manifold located behind the cylinders of the main engine. It is then diverted of the cooling path of the liner where it will flow to the cylinder head, for cooling of the cylinder head system, then will flow out to the series of ports, which then will flow to the water reservoir which complete the cycle. Apart from that, if the temperature is still cool enough for the system, it will return back to the suction line of the jacket cooling water pump. This temperature and pressure is monitored by various thermometer and pressure gauges. Fuel injection valve cooling system. The fuel injection cooling unit is used to cooling fuel injection nozzles of diesel engine to keep the diesel nozzle automatically and lasting cooling by circulating water or oil through cooling passages. Heavy fuel injectors are fitted with water-cooled nozzles. The operations start from the expansion tank where the circulating pump draws water from expansion tank where series of thermometer are directly to cool down the nozzle. After cooling the nozzle, the water will then flows out to the sight glass used for detecting the flow of coolant through its nozzle, which then eventually flows back to the expansion tank. Main lubricating oil system. Main lubricating oil system comes from the main engine lubricating oil sump tank. This oil in the lubricating oil sump tank is being pumped by the gear pump through a series of filters where it will then goes to the lubricating oil cooler. This system is also fitted the emergency lub oil pump to prime the lubricating oil so that it will fill the line prior before starting the main lubricating pump. When the lubricating oil enters the cooler, it will be cooled by the fresh water system that is used to cool the jacket cooling system. After passing the controlling valve, the oil will then be filtered to a second filter to ensure that any remaining particles are being screened off. The oil is then passed to a main part where it will enter into the main engine to lubricate the main bearings, crank pin bearing, of the main engine. It will then flow back by gravity to be collected in the dry sump tank where a pipe will flow back to the main lubricating oil sump tank. Also oil return from gearbox to sump tank. Throughout the system the temperature is monitored by a series of thermometer, thermocouple and pressure sensors. Piston cooling system. Piston cooling system is used for cooling the piston crown to absorb heat incurred to the piston. The piston cooling system is a part of lubricating system of the main engine. The lubricating oil which flow to the main engine lubrication system is diverted to a series of pipe where it enters the telescopic pipe from the underside of the piston. Rocker arm cooling system. The rocker arm lubrication is to provide fluent movement of the rocker arm by providing sufficient lubrication to moving parts such as push rods, bearing bushes, the push rod's ball ends, the rocker arm bearings and the ends of valve stem. Cylinder liner lubricating system. Cylinder liner lubrication start from cylinder liner lubricating oil tank. Then it will flows to rational lubricator. Then rational lubricator will distribute lubrication oil to the cylinder liner at port and starboard of the cylinder liner through lubricating quill. The lubrication oil will be sprayed at the internal liner surface, the scraper ring, and will eventually be burned during the combustion. Turbocharger lubricating oil system. The turbocharger lubrication is supplied either by an external or internal pumping system. The external system requires a positive displacement pump to supply oil from an external holding tank to lubricate the turbocharger bearings running at high speeds. It is very important that the lubricating oil is clean and free from metal particles that could scratch the bearings. The turbocharger lubricating oil system start from oil from overflow tank will be pumped by a gear pump to a series of duplex filters of magnetic type. The system fitted with a gravity tank fitted high above the turbocharger to ensure that all time oil will remain inside the pipe. This is to ensure that no air that could ingress into the system, creating an airlock. Fuel oil system. Marine fuel quality can significantly affect the performance, operation and maintenance of the diesel engine. To better understand the important effect of diesel fuels on the engine itself, it is important to have a basic understanding of fuel characteristics, properties and contaminants which impact the operation of a diesel engine and its fuel handling and fuel treatment systems. The fuel oil system for a diesel engine can be considered in two parts, which are the fuel supply and the fuel injection systems. The fuel supply of this plan start from the fuel oil storage tank. Where it will transferred via a fuel oil transfer pump. To a gravitational fuel oil service tank. In the event that the fuel oil is low through fining in the sight glass. Overflow pipe are fitted to direct the excess oil back to the oil overflow tanks. The system start when fuel from the service tank flows down by a gravity to aerator which separate the fluid and air to prevent airlock of the system. During operation the oil is pumped by a gear pump which is attached to the main engine driven by a set of running gear through the main engine gearing system. Fuel oil will then pass through series of duplex strainer to clean any matter particle that could choke the fuel injector. After passing through service pump it will pass through a flow meter where fuel consumption is monitored. A second duplex clean final metal and sludge from the fuel oil system. This oil will then pass to the fuel injection pump where the pressure will be raised to the fuel injection valve located in the center of the cylinder head. The fuel injection pump being operated by a set of camshaft driven by gearing system at the end of the engine chain drive. This pump is controlled and regulated by the governor to series of linkages that amount of fuel supplied to the injector, as a result the speed of the engine. Scavenge air system. Scavenge air system is provided by an auxiliary blower when the engine is running at slow speed. The auxiliary blower driven by a motor at high speed delivers air to damper which then will enter scavenge space before it entered the scavenge port. After passing the port, the air will mix with fuel in the combustion space inside the cylinder and burn to produce power to drive the engine. After the engine has reached a constant speed, the duty of the auxiliary blower will be taken over by the turbocharger that flow air through filter and compress it to a constant part into air cooler, where the air will be cool prior before it enter the scavenge space. The reason for cooling the air from turbocharger is that when it running at high speed compress the air to a constant pipe, the temperature will raise up and will cause the scavenge air will expand. The expansion of the air will cause inadequate for combustion in the cylinder and will result in complete combustion. Starting air system. Large marine diesel engines are started using high-pressure compressed air. The air is admitted into the cylinder when the piston is just past TDC and continued until just before the exhaust valve opens. There is always more than one air starting valve open. The situation known as overlap. This ensures that the engine will start in any position. The starting air of this plan start from the compress, the two-stage air compressor that compress high-pressure air to air dryer and being stored in 2 air bottle. To start the engine, air will be supplied to the isolating valve through a main starting air valve fitted at the air bottle. The isolating valve is fitted to prevent the starting air line explosion due to faulty starting air valve. After passing, the isolating valve will be divided into 2 flow paths. One, which is the main starting air, will be ready just prior before the entrance to the starting air valve fitted to the cylinder head, while the other will go through the set of distributor that correctly timed the unit that will first start the engine. It will then direct a pilot air to the starting air valve that will let the main starting air valve to enter the designated cylinders. Exhaust system. Exhaust system come from combustion of fuel and air inside the combustion chamber. In this plan, the exhaust gas of combustion chamber is removed through the exhaust valve driven by rocker arm that has been pushed by push rod from the camshaft. The high pressure exhaust gas that is removed uniflow by uniflow method will then enter the exhaust manifold, where the pressure and temperature will equalize. This exhaust gas will then flows to the turbine side of turbocharger, where it will drive the turbocharger high pressure hot gas of main engine. This would result a high rotational speed of the turbine and thus also of blow of turbocharger. Conclusion. After studying this system, student can prepare themselves prior, before, during practical in the 2-stroke diesel engine with appropriate knowledge and skills.